can make a lot of money. What?
Recording your lectures.
Yeah, Tom Ritchie. You charge us
Yeah, charge my students. I think there's a little ethical problem with that. I can get you an A. Give me money.
No, I mean like on YouTube, if you like make videos, post them on YouTube, you can make a lot of money.
Yeah, but I make jokes a lot, and that just wouldn't fly, I don't think.
Maybe like the cool science teacher YouTuber.
I already am the cool science teacher. Thank you very much. Ah, there we go. All right. So, side note: the microphone is right here. So, like, legitimately, I'm gonna email you guys. Actually, I'll put it up on YouTube, and I'll send you guys the link. So if you guys if you watch it, and please do. This is gonna be. I know it's gonna be terrible. But I'm honestly curious. Let's say Nick asks a question versus if Jennifer asks a question. Does that pick you guys up? That's honestly what I'm curious about. Okay, because I can buy a separate microphone because they're like $10, and I'm just kind of curious. Okay, so we have physical hazards, UV radiation, we have natural disasters. Okay, we obviously have chemical hazards. We talked about pesticides a bunch. Okay, pharmaceuticals is a big one. Okay, venom is a big one as well. Okay, a lot of people think that oh, it's natural. Natural doesn't hurt you. Yeah, poisons hurt you. Okay, poisons are from snakes, and snakes make them. Go.
Is cyanide considered natural?
Yes, it is. Because it's part of apple seeds. Yeah. Okay, so remember we talked about that greenwashing stuff? Okay, they talk about if a label says natural, oh, it's got to be better for me. Yeah. No, it's not. Okay, that's part of that greenwashing stuff. Okay, flip to the next one or next page. Now we're at 356.
And that's why snakes are called danger noodles.
They're what?
They're called danger noodles.
You should turn off your comments.
Turn off the comments.
Disable comments.
There's going to be a whole bunch of bad dad jokes just lining this video.
The YouTube comment box. 15,000 comments on there.
All right, biological hazards, okay? There's biological, cultural hazards. Biological, okay, results from ecological interactions. Okay, this is not necessarily a bad thing, but since we're talking about hazards, it definitely is, okay? Infectious disease is one of them. Okay, we're going to spend some time talking about that in a quick second. Okay, ecological interactions, just simply you interacting with something else that's alive. Okay, or things that are alive interacting with other things that are alive. Okay, this is how disease spreads. Okay, viruses cause infectious diseases. A vector is an organism that transfers the pathogen. So you guys know how malaria works?
Yes.
You know, mosquito bites you, mosquito gives you malaria. That's what's considered a vector. Okay, that's the thing that's transferring the pathogen from one thing to another. Okay, go.
Rabies content.
Yeah, rabies can be one, yeah. A dog that has rabies bites another dog and gives him rabies, yeah. Okay, and we'll talk about coronavirus in a bit, yeah.
Do you already have English? Do you already have English?
Yeah.
We took the survey.
Do you have coronavirus?
Yeah.
I ask you if you have online access at home, and they're like, we want to use it for communication, but I realize it's if the school closes for online school. So I'm like, no, I don't have online access.
Well,
I don't want to come to school in the middle of school.
that's the biggest kicker of it all. If we miss school, we're coming back to school.
Except for seniors.
Yeah, except for seniors.
I don't care. I'm not coming back.
What is under biological hazard? Is that vector?
That?
Yes.
Vector. Vector, V-E-C-T-O-R, is an organism that transfers the pathogen. Can't you read my beautiful handwriting? Good answer. You only say that because we're on film.
Wait, are we actually? Oh, I was gonna say that's.
No, it's like that is recording right now.
Can it hear it?
And also our voices.
Yeah, that's why there's a microphone right there. We just talked. You're not paying attention to me? See, this is why I'm not going to be a famous YouTuber. I just yell at you guys the whole time. Huh?
Like Brandon's Ames podcast.
No, but then you got to have like a really expensive microphone.
If you fit in
People, we would definitely have no subscribers because it would not make any sense. Okay, so culture hazards. Come on, we got to move. Cultural hazards, okay? Cigarettes, drugs, occupational hazards, okay? Occupational hazards can be as simple as like an accountant, you sit down all day long. Okay, they talk about these days sitting is the new smoking because it's so unhealthy. Okay, if you sit all day long and are sedentary, that's very bad for your health. Okay, diets, like drinking a soy sauce diet, like we just read about, that's obviously terrible. Okay, your cultural hazards, okay, we talk about like the pesticides that get onto foods. If you're eating all that stuff, bioaccumulation, biomagnification, like that's the part that's going to be bad for you. Plus, if you're like eating McDonald's every day, like diet can play a huge, 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 huge role in your life. Go.
Is it true that you burn more fats when you sleep than you walk?
No.
No.
Okay, next page. Now on to where we at, 357.
This is the one that in your class.
It won't with that.
Okay, so infectious versus non-infectious diseases. Okay, so, Nick, be quiet. Okay, an infectious disease, okay, these are the things that are contagious, okay, like the flu, like the coronavirus, Ebola, SARS, and H1N1, all those kind of different things, okay? Those are things that are contagious, okay? They can also spread very, very, very easily, okay? Dense populations is where they spread the quickest, okay? That's why kind of the coronavirus came out of China. It's not because Chinese are dirty and they can't clean their streets and stuff like that. There's just a lot of them packed together. You know, think of New York City, all the time, everywhere, no matter where you go in the country. Okay, it's basically that. The dense populations make it so it can spread easily. Okay, non-infectious diseases, that's not contagious. Okay, an easy example of this is cancer. Okay, if one of your relatives has lung cancer or pancreatic cancer or breast cancer or whatever, by you being around them, you're not going to like catch cancer from them. Okay, diabetes is one of them. Okay, it's based on genetics. It's also based on lifestyle. Lifestyle should be very straightforward, especially with lung cancer. If you smoke or you vape or you smoke whatever, if you're inhaling smoke, that's bad. That's probably going to give you cancer. Okay?
What about marijuana?
Say it again?
What about marijuana?
Same thing. You're still ingesting smoke. Is smoke good for your lungs? Period. And so like the air quality in like Beijing is really bad. It's the same thing. Go.
The same would apply to gasoline fumes.
Mm-hmm. Literally, think about it. If it's not pure air, it's bad. So like the air quality in university place is pretty good comparatively. Go to Beijing, it's terrible. They equate air quality in cities to smoking however many packs of cigarettes per day. That's how they compare it. Because everybody knows that smoking cigarettes is terrible for you, so let's compare it to something that everybody knows. In Beijing? I knew probably in like early 2000s, it was something between like 3 to 5 packs a day.
Jesus.
Yeah, it was bad.
Like on average, like per person?
Beijing, yeah. Yeah, the worst air quality in the world.
That's crazy.
Okay? All right, so next page. We're actually going to skip. I'll show you these diagrams. Actually, we'll go right there. Okay? So the thing we're about to talk about, okay, is talking about infectious disease versus non-infectious disease. Okay? You can see that infectious disease is only like 17% of the diseases that are out there. Okay, cardiovascular disease, okay, that's like heart disease, you know, like your diet pertains to that kind of thing. But the thing I'm going to talk about in here, okay, this is page 359. Okay, I wrote infectious disease, less than 20% of all deaths, but 40% of years of life lost. Okay, which is a weird way to look at this. Okay, infectious disease, like let's think of malaria. Okay, it doesn't equate to all that many. It's not like the massive majority of deaths, but malaria kills people early on in their life. And so they basically lose a whole bunch of their life. That's where that 40% comes into effect. Their calculation is basically if you didn't have this disease, what would your average lifespan be in that country? And that's where they get that math from. Okay? How we can fight it? Okay, clean drinking water. Okay, in developing nations, that's a big deal. Okay, like my parents are actually really involved in World Vision. Their whole like drive this last like few years is to give Rwanda, the entire country, clean drinking water. And that's where my parents kind of come into involved because like you met my dad. My dad's an engineer, so he can kind of help with that kind of stuff. So that's where they're involved in. Okay, sanitary bathrooms and plumbing is also a big thing. Okay, like back in the day, I'm gonna jump real quick up to this picture here. Okay, back in the day in England, that's animal and human feces. Okay, have you ever heard like with chivalry, the guy should walk on the outside of the sidewalk or closest to the street? The reason for that, so like, let's say that that's the building, the lady should walk there, so that way, no joke, when they threw their crap out the window, it hits me and not her. Like, that's where the chivalry comes into effect.
I would just wait out the window and just be like,
And that's why nobody wants to live by you.
that's why I have no friends.
Okay, so nutritious diet is obviously one of them. Okay, if you're eating healthy, you know you're eating your fruits and veggies and stuff like that, you're obviously going to live longer. Okay, education is a huge one. We've talked about that with birth control and family planning. Okay, if your country's educated on sex education and prevention and all this kind of different stuff, the amount of STDs goes down, the amount of unwanted pregnancies go down. So education is a very, very, very important part of it. Okay, because if you grew up in a developing nation and your drinking water just wasn't clean, that's just what you're used to, and you think that's just how life is. But if you get the education on how clean drinking water affects you, you're going to be driven to get that. Okay? Access to healthcare is obviously a huge one as well. Okay, if you have the ability and your community has the ability to go see the doctor when you're feeling under the weather, they can give you, medicine and stuff like that. That can obviously help your infectious disease rates your infectious disease rates in the country go down. Okay, like, have you guys ever heard of those like Doctors Without Borders kind of people that basically like, you're a nurse and doctor in the United States, you basically raise a bunch of money, you go over to wherever. Like my fiance is a nurse, she went with her nursing cohort down to the Dominican Republic for 2 weeks and just basically did free clinics down there and then came back. Okay, that's kind of the same idea that what they do there. Okay, next page, 360. All right, so infectious disease still threaten human life, okay? Obviously we know that, okay? The what disease affects it changes pretty often, okay? The flu virus, as I'm confident you guys know, evolves every year. So that's why you should get a new flu shot every single year, okay? So infectious disease these days, it's all on the news, is the coronavirus. Everybody's freaking out about the coronavirus, okay? The death rate or the death percentage that we have right now is 3.4%. Is that actually correct? That's kind of up for debate. So it's a couple times more deadlier than the flu. So it's kind of scary, and the biggest like fear from everyone is we don't know exactly how it works, so we don't know exactly how to fight it. And that's where a lot of the fear comes out of. Is like, if you get sick, it's a respiratory illness. If you get sick, we can kind of give you some stuff we think might be helping some of the symptoms, but we don't know how to fight the root cause of it.
So like those people in intensive care, they're just trying to prevent them from dying instead of, from what I understand it. You can't really cure it, but they're just trying to keep the person alive.
They're basically fighting all the symptoms is what they're doing. So like, you have a flu, we give you Tylenol, and they obviously give you much more complicated stuff than that, but like, that's the basic thing. Like, you have this symptom, we fight this symptom and that symptom. Like, we can't figure out how to fight the root cause of it just yet. And that's why everybody's really nervous about it and freaking out. Okay? And that's one of the reasons, like, all the school closures and this, that, and the other. Like, I know North Shore School District, kind of up north, like Bothell kind of area. They closed for 2 weeks. There was a school, I can't remember exactly where it was, basically closed for like 3 days. More not necessarily like, hey, it's coming, but like, we just basically want to just do a really deep clean of everything. And it's basically what it is.
The Kent School District.
Did Kent do that?
Yeah.
Yeah, there's been so many kind of like, this school did it and this school did it, like, yeah.
That phone was so moved to online school.
Online school?
Really?
Yeah.
Oh.
Wow.
Yeah, I don't know. Basically, the way that I roll with all of this is like, I'm going to keep on teaching until somebody tells me that we're closed. Okay, then I'll figure out how to do it that way. Okay? All right, so since our world is getting smaller and we are more densely packed together, disease transmission is very easy. Okay? Especially because you can fly from China to Italy to Sweden to the United States to Brazil within 2 days. Okay? That's the big thing when our world is getting smaller. Okay, it's easier to get everywhere, and that's why the disease transmission, especially with the coronavirus, if you've actually kind of like looked at the arrows, it's going everywhere. Okay. All right, next page, 361. Did I just hear the phrase "the hot pocket"?
No, it is picture.
Oh. All right, so toxicology, okay? This is the study of how poisons affect humans and other organisms. Okay, so if like you're a toxicologist, what you do is try and figure out how this toxin or this chemical affects things. So the study of how poisons affect humans and other organisms. Now, a toxicity, this is the degree to which a chemical substance can harm. So when they talk about like it has a very, very high toxicity, okay, you only need a little bit to hurt something. Okay, and like it says there, dosage is a key factor. Okay, and hopefully you learned that from that very first graph on the worksheet or the packet we did yesterday. Okay, drug A, you needed like 0.01 to kill off 50% of the population. Like that's a very, very, very toxic drug. Okay, and like I said yesterday, the dose makes the poison. Okay, so like, you know, I needed 74 apple seeds to kill me based on my weight. If I eat one apple seed, I'm fine.
What if you eat 73?
Then I'm gonna be not feeling so fine.
Is the 73 like if you eat them all at once or like over a lifetime?
All at once. Yeah, because that's part of the dose is what that is. You know, like if you like if I have a headache, I take an ibuprofen. But if I have a really bad headache, I'm not like, you know what, I feel really bad. I'm gonna take one now and one in 4 hours. You know, like by giving yourself more, it's gonna have a more effect. It's the same idea. Okay, and there's the field called environmental toxicology. Environmental toxicology is growing. I'll move that up a little bit. Okay, like we watched the video the other day that talked about the Duwamish Waterway in Seattle. Okay, those guys are kind of like, that's where that whole movement is starting. Okay, we did that Port of Tacoma stuff. They do a lot of environmental toxicology there, studying the Puyallup River, studying the ports, or excuse me, studying the Commencement Bay, which is the big water, the big bay where Port of Tacoma is. All right, so staying on this page, okay, we're still on 361. Okay, there's kind of a lot on this one, I know. Okay, so PBDEs, okay, these are fire retardant compounds that release into the air during production as well as the life of the product. Okay, and that's a bad thing because slowly but surely, like you're just polluting not only from the factory, but like if it comes to Home Depot, and then it's Home Depot's polluted a little bit, then it goes to your house, and then your house is polluted a little bit. Okay, that's the big thing. Fire retardant compounds that release into the air during production and life of the product. Mm-hmm.
What does retardant?
Retardant, like it, they won't catch on fire. So like firefighters wear fire retardant like uniforms, so that way when they're in the house, it protects them. Okay, second thing I wrote there, or the second little paragraph, these chemicals persist and accumulate in living tissue. Okay, again, persist meaning they're basically sticking around. They're not going anywhere. They're not being biodegraded by your body. Okay, they stick around, they're persistent. And they accumulate in living tissue. So if you slowly but surely are giving yourself more and more and more, you're just slowly but surely accumulating more of that toxin. Okay, they've been doubling every few years in the United States. So they take blood samples of people just to study specific stuff like this. And they've noticed that the blood amount, or the amount in the blood, has been doubling every couple of years because of these PBDEs. It's, where is it? Polybrominated diphenyl ethers. Okay, this last part here, okay, acts as a hormone disruptor and also affects development of brain and nervous system. Okay, this hormone disruptor, they also call what's called an endocrine disruptor. We'll talk about that, and that'll be written down in another couple pages. Okay, a hormone disruptor basically means it either is acting as a hormone, like kind of mimics it, or it makes it so the hormone doesn't work at all. Okay, both of which are really bad. Okay, and we'll talk a little bit about, like, you know, it literally can change the frog's sex from a male to a female because of the amount of the hormone disrupting that's going on. Okay, it can also, like in humans, it can make puberty happen early. It can also make puberty happen very late, or does puberty not happen, period. Okay, and that's the big thing with this hormone disruptors. Okay, so next page, going to 362. All right, so we go, I'm a little bit sideways there. Okay, we can talk about what's called a cost-benefit analysis. And we've talked about these before. Okay, so cost-benefit analysis is the cost or the harm to us and to our world bad enough to ban something. Okay, and this is where kind of like science and government can either work together or they will fight each other. Okay, because basically science is saying one thing, the government, which is backed by a whole bunch of, you know, corporations, and the corporations got money, they're going to fight back. That's kind of where science and government aren't friends. So cost-benefit analysis is the cost or the harm to us and our world bad enough to ban something. Then the bottom part, we all have synthetic compounds in us. It's impossible to avoid. Like the other day we watched that video where the fetuses, those 10 Americans, they already had things inside of them. Like at the very bottom of this page actually even says, our exposure to synthetic chemicals begins in the womb, as substances our mothers ingested while pregnant were transferred to us. A 2009 study by the nonprofit Environmental Working Group found 232 chemicals in the umbilical cord of 10 newborn babies it tested. 9 of the 10 umbilical cord contained BPA, leading researchers to note that we are born pre-polluted. So you come out of the womb, you already have synthetic chemicals in you. Okay? The BPA, I'm not sure if you guys have heard about that, it's part of like plastics. Okay? And so like a lot of like the newer like reusable water bottles talk about BPA free because the BPA kind of leaches into the water after a while. Yeah, that's one of the things that we talk about, and that's one of the things in the video I talked about too. Okay? Where are we at? 363. You're now like, All right, so pesticides and DDT are very, 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 very harmful to humans. Okay, DDT is a really, really bad one. Okay, we banned DDT in like, I want to say 76 or 72, something like that. Okay, the United States did. Okay, so pesticides and DDT are very harmful to humans. So if you guys go to the store and you buy your apples and you buy your carrots and whatnot, okay, you always want to go home and wash everything because it might have the pesticides on it. Okay, by washing them, and they're not getting them 100% clean, but at least you're getting some of it off, and that's a good idea. Okay, we talked about malaria earlier. Developing nations use DDT to control the mosquito population. So with them, their cost-benefit analysis, malaria is much more of a problem in their country, in their community, than pesticides. That's their cost-benefit analysis. They need that DDT to try and help people not get malaria. That's a very, very, very big deal for them. Go.
So, in my history class, we were talking about Agent Orange.
Uh-huh.
Vietnam, and how it created a bunch of hormone defects in either like people who were using it in Vietnam and people who were being sprayed by it in Vietnam. So is that an example of something that's like what was it?
So that would be an anthropogenic,
Androgenic, yeah.
definitely.
Okay.
Yeah, so basically Agent Orange, what it did, it basically just like you drop a bunch of it on it and literally it would just kill all of the plants. So that way, and their use for it is they basically now they can see kind of thing. And so a lot of the Vietnam veterans as well as the Vietnamese people, got hurt a lot by it. Like one of my roommates in Hawaii, actually, he spoke Lao. And so one of the things that he'd do is he'd basically go over to Laos and to Vietnam and Thailand and basically like interview the people over there, like, hey, have you guys seen, basically, have you seen Agent Orange or Agent Orange like areas? And because part of the U.S. Army at that point was like to go over there and like if it's still there, we need to clean it up. Like that's not cool what we did. Sorry about that kind of thing. And so basically his job was to go basically mark where the places were. So it's the same basic idea as this pesticide and DDT stuff.
Okay.
Yeah, man-made, really bad. Go.
You know how you're talking about washing fruit before you,
Mm-hmm.
is that why people do the same thing with rice?
Huh?
Yeah.
Yeah, same idea. Yeah.
Oh yeah, what do you call the white stuff when you clean the rice?
Technically, that's leachate. Remember we talked about the leachate is basically just water that's gone through something? Yeah, so it's basically just, and it's not necessarily like horrendously bad for you. It's just like kind of the extra kind of like dust, potentially, that's on it. Okay, not all natural chemicals are good for you. Think about plant poisons. Okay, plants have developed things to basically make it so they don't get eaten by like little herbivores. Okay, the same thing that's going to hurt the herbivores hurts us if it accumulates enough. Okay, obviously we weigh a lot more than the little ladybug, but if we get enough of it in us, that's where it starts to become bad. Okay, again with that greenwashing and a natural label, it's not always good for you if it's a natural thing. Okay, 364. 364. All right, so there's a lot of vocab on this page. You don't need to write down those 2 lines. A lot of vocab on this page. Be familiar with them. If you want to write it down, go for it. There's a lot of kind of the bold words. The endocrine disruptors, I'm going to move this real quick, okay, is in that side. It's like the second paragraph. That's the thing I want to talk about and kind of highlight because a lot of the APES questions talk about the endocrine disruptors. Okay, so I talked about it really quickly, but the endocrine system is what controls hormones. Okay, like that, you know, like for guys, it like releases more testosterone. It knows it needs to release more testosterone because we're male. For females, it's more estrogen. Okay, disrupting that system either can hasten or diminish hormone signaling. Okay, and this is not only for just simple things like puberty, but like if a female gets pregnant, the amount of hormones that go, there's a thing called relaxin that starts, that no joke, like, I'm not sure if you've seen the anatomy, but when a woman gets pregnant, her hips literally twist open a little bit. So that way the head of the fetus can fit. That's a thing called relaxin. It basically kind of like, as the name implies, relaxes your like joints, like the ligaments and stuff like that. Oh yeah, best part about being a dude is no labor. Oh man. Still, God, I can't imagine that. Harold, you're so encouraging. Okay, so disrupting that system can either hasten or diminish hormone signaling. Okay, so again, like we were talking about, puberty can either happen a lot earlier. You know, like when I taught freshmen, I had a freshman a couple years ago that had like a full-on beard. And he's 14. Yeah, that's the thing. Is like you can think of those guys that like, you know, those guys or those girls that just have hit puberty already, and you know those guys and girls that haven't hit it at all. Like, and that's the thing. That's what this endocrine disruptor stuff is really bad about. Okay, next page, 365.
Oh wait, this should be.
Yep.
Is it true when you do more sports or workout, you get more weight because you release more testosterone than usual?
If you're not taking care of yourself, like if you're not like doing like recovery days kind of thing, you'll wear your joints and your muscles down. But if you're, you know, like, and recovery is like 2 days a week.
No, I mean like how
So-
you look.
Huh?
I mean like some people that's younger than you look older than.
They look older?
Yeah. How do you
Typically, those are the ones that have started puberty earlier, is typically what that is. So they just kind of like appear to look older. You know, they're bigger, their muscles develop faster because of it. That's the issue. All right, so 365, okay, organisms sequester toxins they cannot get rid of into fatty tissues and cell membranes. Okay, so when people talk about, or if you've heard the term, it is fat soluble, that's what this means right here. Okay, your body, for example, we were talking about, I forgot the name of the town, it starts with an M in Japan, we watched the video yesterday. The mercury. Okay, their body doesn't know how to get rid of it. Therefore, they sequester it or they put it away in their fat. Because basically they don't have an ability, your body doesn't have an ability to get rid of this kind of stuff. Okay, so organisms sequester toxins they cannot get rid of into fatty tissues and cell membranes.
Is that like it's defense mechanism?
Yeah, basically, yeah. Yeah, they know it's going to hurt an organ if it's just roaming around free in the body, so we're going to grab it and stick it here just to kind of control it. Okay, so these pictures here, okay, this is going back to the endocrine system. Okay, there's your inside your cell. Okay, there's the receptor, there's the hormones. You can see they fit like a lock and key or like a puzzle piece. Okay, hormone mimicry, this is like one of the things that basically like that's a toxin. Okay, that will mimic a hormone. So it'll tell the cell to do stuff even though your body hasn't released the hormones to tell your body to do that. And that's where like early onset of puberty occurs. If you get a bunch of that kind of stuff, it's going to tell you to grow. It's going to tell you to get a big massive beard when you're, 13, 14. I wish I had that. I can't grow a beard. All right, 366. Okay, there is acute exposure as well as chronic exposure. Okay, acute versus chronic. So the acute exposure, this is high exposure in a short period of time. Okay, so I wrote down i.e. an oil spill or accidental ingestion. Like when you're a little kid, there's, the medicine cabinet, you got to put those things high up that the kids won't swallow. Yeah, that would be an example. Okay, say it again.
I said fun fact about me. I ate my grandma's pills when I was younger. I had poison control because I thought they were candy because they're like colors.
Oh, no joke. Like,
Yeah.
you guys know what Tums are?
Yeah.
I thought Tums tasted great. And so I always lied to my dad, oh, my stomach hurts. Can I have some Tums? Because I just loved them. And so that's kind of the same idea. Like you basically like accidental ingestion. Okay, that's an acute exposure. You need to go get help right away. Okay, oil spill's the same thing. So when an oil spill happens, the whole bunch of environmentalists run down there to like, grab the seabirds and clean them off because they need help really, really, really fast.
Is that why like certain chemicals they have like that green
Uh-huh.
sticker with the guy on it?
Yeah, Mr. Yuck.
Yeah, and
Yeah.
it's like if you ingest it, calls it.
Yeah, exactly. Yeah.
Call, get this thing out of control.
Yeah, they'll go take you to the ER. They'll pump your stomach, which basically they stick a. You guys know what Epicac is?
Yeah.
Epicac makes you puke.
You know how like with like mouthwash, it says not to swallow it. So like when I was little, I like swallowed like a little tiny bit of it, and I started crying because I thought I was gonna die.
Oh, totally.
And then I like ran to my dad and I was like, we need to call the people. We need to call this number. Like how much? Like
A lot.
A lot.
Because think about it in a very realistic sense. Does Scope know that probably people are going to swallow some of it accidentally?
Yeah. Oh my gosh, I was so scared.
Yeah, and I agree.
I was,
Like,
crying.
yeah, it's not good for you, but it's not going to hurt you. That kind of thing. Go.
I used to eat toothpaste.
Like my strange addiction.
Oh, jeez. Okay, chronic exposure. Okay, this is low exposure over a long period of time. Okay, this is like smoking or drinking alcohol. Okay, like slowly but surely, and we're talking, obviously there's alcoholics. Okay, they'll burn through their kidneys, they'll burn through their liver really fast. But low exposure, in college, there's binge drinking. Okay, so binge drinking can be the same, if not worse, than just straight alcoholism, like over a lifetime. Because alcoholics typically they'll drink 2 or 3 drinks a night, kind of thing. But binge drinking every weekend, you're putting down 20 beers. That moves from chronic exposure to acute exposure. And so that's where it can almost be worse. Go.
Isn't that like alcohol poisoning?
Very much so. Same exact thing. Okay.
Wait, which one's radiation exposure?
Which one's what?
Like radiation?
Radiation?
Yeah.
That depends. If you're in a nuclear meltdown, that kind of radiation, that's acute. Okay? Radiation is like if you have lung cancer, so you're getting radiation therapy, that's chronic. So it's not necessarily one or the other. All right, 367. All right, toxins can travel the world.
Must be.
It's like a Disney song. Okay, toxins can travel the world and affect organisms far from their toxin source. I'll show you a picture of this actually on the previous page real quick in a second. Okay, air currents and water currents move them all over. A good example is the amount of toxins that are in polar bears and penguins is ridiculous compared to where they are. Okay? They're literally hundreds and hundreds and hundreds of miles from any civilization. But somehow they're getting DDT in them. Somehow they're getting BPA in them. Okay, that's the problem, is those toxins can travel everywhere. Okay, one of the things about like the LA Valley and California is they do a whole bunch of agriculture stuff in the Sierra Nevadas, but the wind will take that stuff over to LA. So all that pesticides basically gets blown into the big massive city. Okay, I'm gonna move this real quick to show you that picture. Okay, it should be pretty straightforward. Okay, the oceanic currents move stuff around. Okay, evaporation, deposition goes, all that kind of stuff. Like, that should be pretty straightforward because we understand how the basics of that stuff work. Okay? Like I said, this should make pretty good sense. If you want to look at that picture, originally this looks like, oh crap, everything's coming to us, we're all going to die. Okay? But if you actually look at it, it's not actually too bad. Consumer products, yes, we buy them. Workplace exposure, yeah, the air quality sometimes in the workplace isn't the best. You know, like if I'm like a mechanic, I'm smelling oil and gas fumes all day. Okay? What is that? Medicines and materials? Yeah, like I had a headache, so I took some medicine. You know, so like food, drinking water, air for breathing. So like, it looks terrible. If you kind of keep an eye on it and what you're being exposed to, you'll be fine. Okay? All right, where are we at now? 368. What?
I think you skipped some of the there's
That's all from that's all on 367. Okay, 368. A little off center there. All right. So most toxins degrade into similar compounds over time. Those are what's referred to as breakdown products. So DDT, like we've been talking about, is so terrible. DDT will break down into a thing called DDE. Okay? That is also a very persistent thing. That is also something that's very toxic. It's just a different form of it, basically. Okay? So it's not necessarily it breaks down and, oh, that's a good thing. It breaks down, it goes away. No. Okay, DDT, even if it breaks down, and other pesticides that they break down, they're still breaking down to the things that aren't nice. Okay, and this bioaccumulation and biomagnification, okay, there is a difference between them. Okay, we've talked about both, but I want you just to double check that you know the difference between them. Okay, a bioaccumulation is one organism's concentration is increasing. So if I am eating mercury-laden tuna again and again and again and again and again, in me, I am going through bioaccumulation of mercury. I'm getting more of it. Me, it's basically about one single person or one single organism. Okay? Biomagnification, that's talking about the food chain. So like it's a much broader sense, you know, the primary producers, the primary consumers, the secondary consumers, tertiary consumers, it's the whole pyramid. That's biomagnification. That's the whole process behind it. Okay, if you're just talking about one person or one organism, bioaccumulation. Okay, so double check you use those terminology or use those terms correctly. Okay, because that's going to be an easy thing to mix up. And typically when I talk about this, I'll say bioaccumulation and biomagnification.
So, it's like when you were talking about how, like, the fish that we eat, if they ate something that was toxic, okay.
Exactly. So if the primary producer, which is the eelgrass, gets a little tiny bit of toxin in it, it's not bad. But then the little fish that eats the grass, they get a little bit more. They bioaccumulate more. The bigger fish eats a bunch of those guys, so it bioaccumulates more, and then I eat the tuna. Like it's just kind of increasing as we go higher and higher and higher.
So that's biomagnification.
Okay, next page, talking about which is 369. Basically, that dude is taking he's taking blood samples from an alligator. Okay, what he noticed, okay, is that if there's more toxins, the alligators and the female alligators aren't like laying very good eggs and they're not surviving. So this guy started testing in the lab with frogs, and he realized the same exact idea. So basically, he's just talking about lab science versus field science. Okay. Where are we at? We got a bunch Where's to go? Okay, we're gonna skip. Go to 374. Okay, like legitimately, I want to get through two more sticky notes. Okay, so synergistic effect. Okay, the guy actually talked about this in the video. If you have one chemical that you know is bad, and that gets dumped into the Duwamish Riverway, and then another chemical that's bad gets dumped into the Duwamish Riverway, if both of them come together, is that worse? And the guy, I believe the guy even said you nailed it right on the head right there. And that's what synergistic effects is. If you have two things that are bad, sticking them together can potentially make it even worse. And that's where a lot of the environmental toxicology is coming into play. Because they need to test if these two bad chemicals link up, what does that do? Okay, so one chemical can be bad, but add other chemicals to it, and it can really get out of control. Okay, the endocrine disruptors, if you don't want to write that down, that's fine. Endocrine disruptors may be the reason for breast cancer frequency increasing. So basically, if you're messing with the hormones in your body, this can potentially cause breast cancer or other just in general tumors to start developing. Okay, so these endocrine disruptors, just be familiar with that because I know that on your test it's going to talk about endocrine disruptors a few times. Okay, so 376. Okay, don't write stuff just yet. You see on the very bottom how I say know this chart? Okay, this chart is this thing that I'm talking about right here. Okay, risk assessment, so scientific data on. So we meaning scientists, we determine the risk assessment. Okay, we take that information, we present it to the risk managers. That's the government, that's the EPA. Okay, information, opinion, and lobbying from private citizens, industry, manufacturing, and nonprofit interest groups. Okay, political, economic, and ethical considerations. Politicians to weigh all this kind of stuff. They make policy. That's basically where it starts. So everything starts with the science in the beginning, then it got to go through the government, the oversight process, and then that turns into policy. Okay? There are two approaches on how to deal with new chemical substances that are coming onto the marketplace. Okay? You either, and they sound very, 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 very similar to each other, but they obviously are a big difference. You either assume that they are harmless until they are proven harmful. So they also call this the innocent until proven guilty philosophy. Or you assume that they are harmful until proven harmless. So you assume guilty until proven innocent. Okay, those are the basic philosophies. Okay, and those are obviously two massive extremes. The government around the world deal with different versions of this, as well as somewhere in the middle and back and forth. Okay, it's kind of a sliding scale to it all. And that's it for today. That was a lot of talking. Okay.